name is Hunter Levitt, and I'm part of the OpenFarm team. The other team members are Matthew Elliott, Joshua Schell, and Tyler Peters. I'd like to take some time to introduce you to what we've created over the last year. 3D printing is an incredibly powerful tool, but one that can be difficult to use. To mitigate this, users often turn to 3D printing services. However, these services are expensive. We wanted to lower the barrier to enter into this space, so we created OpenFarm. OpenFarm is an open-source, Dockerized microservice system designed for managing distributed fleets of 3D printers. Built in partnership with the Marriott Library's 3D printing service, it incorporates operational insights for managing thousands of real client print requests. Our core users are the operators and administrators of a 3D printing service, such as the aforementioned Marriott Library. Their primary concern is fulfilling client print requests while minimizing the amount of manual work required on the part of operators. During our collaboration with the Marriott Library, we identified many issues with their existing system. Some of the key points that were repeated were an inconvenient operator interface, a limit of 1 print per submission, prints being able to be issued without payment rendered, no operator notification system for outbound patron communication, and printers being damaged by malicious or just ill-formed G-code. Now, if you'll please turn your attention to the screen, I'd like to display our job lifecycle diagram. Now, this is the path that the average print request is going to take through the system. So first we begin with our patron, and our patron wants to be able to print some form of arbitrary G-code. They will navigate to our Google form that we've configured, and they will submit to us information such as the G-code they'd like printed and the channel of communication they'd like to use. At this point, our file service will download that G-code and pass it to the print submission processing service, which is going to perform some checks to validate that the G-code will not in fact damage the printer. Now, at this point, our farm operator reviews the file to ensure that all the determinations made by the system are in fact correct and that it can be printed, at which point the user is notified that they must pay for the print. After they've paid for the print, this gets passed to our print management service, which will actually do the work of issuing the print and ensuring that printers are ready to take it, tracking when it's done, and all of that good stuff. Once all of that completes successfully, the print is officially finished and the user will be notified via their email. Now, I'm going to pass this demo off to my colleagues Matthew and Tyler to tell you a bit more about the operations.
Hello, I'm going to demo our OpenFarm system for you. Everything begins with the patrons submitting a print request, so I'm going to go ahead and do that now. So once the form has been submitted and the file service has downloaded it and the print submission processing service has checked the file, the next step is for a farm operator to come into the farmhouse software and review the submission. That can be done on the staff review tab right here. You can see the most recent job I've done from user Matt Elliott is right here. We have a preview that is rendered of the G-code so that it can be quickly reviewed. And this can be rotated through to see different angles of it. So we have a full 360. I know that this G-code is pretty good, so I'm just going to go ahead and mark that as approved. Once it's approved, the next step is for the user to be notified about that and pay for it. And find that job PR17 right here, and I'm going to mark that as paid. Now that PR17 has been paid for, you can see that it's in our print queue and it's now pending. We can go to our home screen and check out our printers. You can see Prusa 1 and Prusa 2 are the two printers live in this demo, are both printing. And they're printing, one of them actually does have our job. So Prusa 1 has PR17 that we just started. I go back to our print job screen, PR17, I can see that that's printing on Prusa 1 right here. These are virtualized printers, so I can actually pull up the printer interface right here, and we can see our job 17 G-code is printing on the printer. So once that's finished, we will be notified that it has been finished, and then we'll be able to go pick our print up.
Thank you, Matt, for walking us through that. So I'm going to show you a couple of the other tabs that we have on the farmhouse. So right here we have our printers tab where you can see the name of our printers, the models, their IPs and API keys. As you can see that these two haven't been set and now they have these. We can set them to enabled or not if they're ready to actually take them, and we can delete them as well. Here we have our messages screen. As you can see, we can actually open a log and see what someone has emailed us. And as you can see, we have these AI drafts that will allow you to actually have a draft for you to send to the customer, and this is really helpful because it won't actually just send. We can have the operators actually review this and then send the reply. So we have a users tab as well. As you can see, we have their user IDs, their names, their email, and whether or not they're blacklisted. We can also delete them as well and edit it. Over here we have a quick stats overview. As you can see, we've had total of 18 print jobs. They've all been done on Model 1, and our longest jobs and such. On our configuration screen, we have all of our materials that we currently have. We have our printers that are currently in operation. And we also have these time-based auto configurations.
Our goal was simple: create an open source, system agnostic solution that any university or institution can use to support and grow its 3D printing community. And this starts with our architecture. We built a containerized microservice system utilizing Docker and the .NET ecosystem. Each responsibility, whether that's submission, printer management, payments, notifications, runs in its own service. When demand spikes, we scale only what is needed. More jobs, scale submissions. More printers, scale printer management. The system grows with you and scales to your needs. At the center of it is RabbitMQ. It is the message broker that connects everything, from submissions, job validation, printer status, notifications. Services communicate through events so that they stay loosely coupled, resilient, and easy to evolve. For data, we keep things simple and secure. Postgres stores our core records, such as jobs, users, and printers. MinIO handles our heavy, large files, such as G-code files and our image files, so that large assets are stored efficiently without slowing down the system. We integrate tightly with Google's ecosystem. Google Forms lets patrons submit jobs in a familiar, easy way. Google's API pulls those submissions into our pipeline so that we can send automatic email updates so patrons always know what is happening with their prints. On top of that, we have built focused services for real-world needs. A printer management service that talks directly to Octoprint to schedule and monitor prints on 3D printers. A payment endpoint that allows institutions to plug in their own payment solutions into the service. A submission processing service that validates G-code before it can even ever touch or hit a printer. A custom G-code shader rendering solution to allow for custom file viewing and identify issues with G-codes, just to name a few. At the center of the operator experience is our desktop app, known as the Farmhouse. The Farmhouse is an all-in-one control center for the entire system. It manages which materials are offered, defines and configures the printers on the farm, and it automates email windows of automated messaging so staff can review or customize communication when needed. It dynamically reflects every job, every print in real time. One place to see, control, and manage the entire operation. Because it's built with Avalonia, the Farmhouse is able to run on Windows, macOS, or Linux, giving the operator the same powerful interface no matter their platform. For live operations, we round it out with a Discord bot that delivers real-time notifications and lets the operators query the system from anywhere. Together, this gives us a scalable, resilient, and open architecture, and a complete end-to-end solution for managing 3D printing at scale. This isn't just a way to run printers, it's a foundation for building a 3D printing community.